Bagi aku.
Assalamualaikum. We from group number 4 and I am member number 1.
Number 2,
And member 3, 4.
we have chosen our scope.
And our scope is around UMK Jeli campus field. Let's see how we solve our problem.
Had chosen our scope. The scope is UMK Jeli campus football field. So my problem is how to optimize the viewing angles of the grandstand. Aim is to ensure that each row of the grandstand provides an unobstructed view of the field. If this, we need to calculate the optimal height in each rows. So basically for the height of each rows that I got from my research results, for the first row is 1.5 meters, for the second row is 2.0 meters, while the third row is 2.5 meters. So we can see the grandstand have 3 rows, which is the distance from the field is 5 meters, 7 meters and 9 meters. So the total height is 6 meters. Okay, I got the source, which is as stated. The distance for the first row is 5 meters, for the second row is 7 meters, while for the third row is 9 meters, and the total height constraint is 6 meters. My objective is to maximize the total viewing angle, while ensuring the total height is not exceed 6 meters. We can see here that the total height constraint is not more than 6 meters, where height 1 equal to 1.5 meters, height 2 equal to 2.0 meters, and height 3 equal to 2.5 meters. All these rows when added must amount to 6 meters and not above. Derivative, I calculate the critical point by setting it like this. We already know the sum of height and distance just now, so we go to the step to calculate for row 1. Alright, for row 1, to the equation is delta 1 equal to tangent negative 1 multiplied by 1.5 times of 3, and the answer is 26.56505118. For the second row is delta 2 equal to negative tangent 1 times 2.0 tens of 7 equal to 15.94539959. For the third row is delta 3 equal negative tangent 1 times 2.5 tens of 9 equal to 15.524111. For us to calculate the total viewing angles, we need to add all delta 1, delta 2 and delta 3, which is 26.56505118 plus 15.94539959 plus 15.524111, which the final answer is equal to 58.03455.808. This allows us to find the optimal height for each rows that maximize visibility. This height ensures that every spectator has a clear view of the field. With this design, we have used calculus to enhance the spectator experience, demonstrating how derivatives can solve real-world problems. That's all from me. We go to our next member.
Assalamualaikum and good morning to everyone. Now it's my turn to talk. My problem and what the solution. my problem I get is what's the lightning brightness living optimal in the court futsal UMK Jeli. We already know futsal is one of the best activity every student playing there. So to solve the problem, we need to search the optimal lightning level brightness. To solve the problem, we need to do equation V equation 100 minus 4L. We need to exchange the place like Okay, next we set the formula to find the critical point. We use the formula. We put the number 100 minus 4L equals to 0, and we get 25. Okay, and we get the 25L. This 25 is the optimum level brightness for UMK futsal Jeli. That's all from me. Now let's see member 3.
Hi everyone, and I'm from group 4 and member number 3, and my scope is about UMK Jeli campus and netball court. So here's in the evening, many students are playing netball here. The problem is how the slope of the netball court affects water drainage. Surface like this netball court, we can see if there's no proper slope, it can lead to rainwater to pool. So it can lead to unsafe playing condition and also damage to the netball court. So to prevent this rainwater from pooling, we can calculate the optimal slope for effective drainage. Here's where we are using derivative. So let's assume that this court has a slight dip and we are using function to represent the height.
The function of the height is equal to 0.02x plus 0.03y plus 5, and the x and y will represent the distance in meter.
So to find a slope for this court, we are using partial derivative.
Step 1 is calculate the slope in the x direction, which is dh per dx. So we need to take the partial derivative of the function height with respect to x. dh per dx will equal to 0.02. Next is we also need to calculate the slope in the y direction, which is dh per dy. We need to take the partial derivative with the function of height with respect to y. So dh per dy equal to 0.03.
So gradient is the slope of the surface, showing how steep it is.
Here's where we need to calculate the gradient magnitude. As shown in the video, the formula for gradient magnitude is the square root of dh per dx square plus dh per dy square. Next, we need to substitute the value for dh per dx, which is 0.02, and dh per dy is 0.03, and the calculation is shown in the video. Now we get the final answer is 0.036.
So this value will help us to determine the steepest path of the water will flow. So the overall gradient for this netball court is approximately 0.036 or 3.6%. This slope is sufficient for water drainage, and again will ensure that the waters will flow off the court instead of pooling during rainy days. That's all from me. Thank you, and I'll pass to the next member.
Hi, my name is Akma. I am a group member of 4. I am the members 4. The problem that I will solve today is the head of the grass that university want to optimize for the upcoming event. Today, I will explain how we can rate the change of the growth grass after 3 days. we need to find the derivative and evaluate it. Given the height of the grass on the field is according to the function.
The function is ht equals 5 minus 4e to the power of negative 0.2t.
ht is the height of the grass in centimeter. e to t is exponential decay term. To calculate the growing grass after 3 days, this is the derivative according to the function.
First, the derivative of the constant term 5 is 0, as constants do not change. Next, for the term negative 4e to the power of negative 0.2t, we applied the chain rule. In this case, u equals negative 0.2t. After applying the chain rule, we simplifying this expression as h prime of t equals 0.8e to the power of negative 0.2t.
This is the result. Now we need to substitute t equal to 3 in ht, so we find the growing grass of the field.
After substitute t equals 3, we get h prime of 3 equals 0.8e to the power of negative 0.2 times 3. After simplifying the exponent, we get h prime of 3 equals 0.8e to the power of negative 0.6. Next, using the value of e to the power of negative 0.6, which is about 0.5488, we substitute h prime of 3 equals 0.8 multiplied by 0.5488.
After 3 days, the grass is growing at 0.439 cm per day. That's all from me. Thank you.